Hi everyone, welcome. This is the review for the rational functions test. A few things to note. I forgot to erase these guys, so sorry. So we don't need to do the points of discontinuity because we're going to already state them with the holes and the vertical asymptotes. We're going to find the x-intercepts and the y-intercept, horizontal asymptote, domain, and range. So let's get started. We're going to do not all the problems, but some of the problems. So let's get started. Number one. So the first thing to do is always to factor. So see if we can factor things out. So we're just going to set that equal to, I notice on the top it is linear, but I notice that there is a 3 and a 6 that I could pull out. So we're going to take out the GCF. So it's 3 parentheses and then x minus 2, because 3 times 2 is that gives us back that 6. And then we're going to factor the bottom. If you guys want to do the crisscross method, we know those are x and x, because x times x is x squared, and then we go to the last one, two numbers that multiply to 2, and I know it's like 2 and 1. I know one of them has to be negative because it has to multiply to be negative, so that means that, and it has to add up to -1, and there's that invisible 1 there. So that I know that it's going to be -2. Just to confirm, that's going to be x times -2, which is -2x, x times 1, which is x. If I add that up, that's going to be -x, which is the same as that middle term right there. So my middle, the denominator is going to look like x minus 2, going straight across, and x plus 1. All right, and I notice, as you may have noticed, that there is a hole. So we can cancel out x minus 2 because they're both exactly the same on the numerator and denominator. So I know that that is going to be our whole. I'm just going to write down the simplified version. So it's going to be 3 over x plus 1. So I'm going to be using this. So I'm just going to talk about the whole right here. I like to label what I'm doing so that when I look back at it later, I know what it is. So here we go. I know x minus 2 cannot equal 0, so I'm going to just let it equal to 0 so I can figure out what the whole is. And I know if I just add 2 on both sides, x equal to 2, of course 2 minus 2 equals to 0. So we know that the x-coordinate of the whole is at 2. And what about the y-coordinate? We're going to plug the 2 back in right here into the simplified version right here, because honestly if we put it back into the original, the denominator is just going to be 0 because of, that guy right there. And sad days, we can't do anything with it. So again, we're going to do f of 0 is equal to 3 over, that's going to be 2 plus 1, which is 3 over 3, which is 1. So I know that the whole is going to be at 2, 1. So I go over to 2, 1, just draw that hole right there. Okay, and let's go with the vertical asymptote. Vertical asymptote, well, do purple. So for the vertical asymptote, we take what's left over. So in the denominator, we have the x plus 1. We know that x plus 1 cannot equal 0. So here's my vertical asymptote. X plus 1 equals to 0. So x is equal to -1. Subtract 1 on both sides if you want to do it algebraically. And then, so this is our vertical asymptote. And we're going to go over here. So we know that x cannot equal to -1. Why? Because it would make it so that we're dividing by 0. As you know, we cannot divide by 0. I make it dotted because it's actually not part of the graph. It's just a guideline. All right, and now we're going to work on the horizontal asymptote. We'll make that blue. Now the horizontal asymptote is, I'm going to move that up just a bit. The horizontal asymptote is basically the end behavior, okay? It's what is what y is going to, what the function is going to approach. So here we go. We're going to basically just look at the first two terms. The top leading the top leading term and the bottom leading term. So y is equal to 3x over x squared. because ultimately if we're looking at end behavior, basically when x gets very, very large, minus 6 is not going to matter. Same thing with the minus x minus 2. So that's why we look at the first two. And I simplify what I can. I can take out an x from both of them, so I end up just getting 3 over x. And so I think to myself, well, what happens when x gets very, very large? Like a billion. It's 3 out of a billion. That's pretty much close to 0, right? So this is why we say it's pretty much going to be 0. Because again, horizontal asymptote is referring to end behavior. So y is equal to 0. All right, and we're going to just draw that right here. So we know that the function is going to approach 0 as we go, as x gets very, very large. Okay, so now we have that, and we're going to find the, okay, honestly, when we have the horizontal asymptote at 0, we know we're not going to have any x-intercepts. But if you wanted to look for the x-intercepts and you just wanted to try it out, this is what you would do. Let's see, make it, what did I not use? This magenta looking color. So for the x-intercept, let's see if I have, I'll go like, I'll squeeze it in. We'll squeeze it in on the left right here. So x-intercept is going to be, we're setting, basically remember if we're finding the x-intercept, we want y equal to 0. That's when y is equal to 0. And I'm going to use the simplified version here. So x 3 over x plus 1. So how do we solve for that? Remember, we're going to multiply both sides by the denominator, so times x plus 1 times x plus 1. So remember, anything times 0 is just going to be just 0. And these are going to cancel out, and all we have left is the 3. And does 0 equal 3? Do you notice how we have no x's left? Yeah, this cannot be. So you just say there are no intercepts, or x-intercepts, I should say. I'll just go no x-intercepts. There we go. And so now let's find our y-intercepts. We'll make this black. So y-intercept. And do you see when I label it like this, I can see exactly where each feature is, each characteristic is, so it's easy to tell. So please make sure this, for these kind of things, organization is key. Okay, so for the y-intercept, that's when x is equal to 0. So we're going to do, oh dear, sorry, the lights went out. That's when x is equal to 0. So I'm going to use the original, I'm going to use the simplified version. You can use the original too, it doesn't matter. When you plug in for 0, that's just you're just going to have -6 over -2 left. Or here it's going to be 3 over 1 left. Either way is the same. Since the simplified version is so simplified, and there's not a lot going on in the denominator, I'm just going to use the simplified version. Feel free to use the other one. It does not matter. Usually, I normally use the original, but this is fine too. So 3 over 1, which is just 3. So I know that my y-intercept is going to be 0, 3. If I could fit it in there. All right, so 0, 3. There we go. All right, and I noticed that on the left-hand side, I don't have any points on there. Most likely, it's going to be over here on because they usually crisscross like that. So it's going to be down here. I'm just going to verify that. I'm just going to pick a point, and I like to pick one that's close to the vertical asymptote, just because anything further down is like you're going to be some fraction. Trying to avoid those. Just saying. Let's see here. Am I running out of colors here? Let's see if you can see blue, green. All right, so here's my random point here on the left-hand side. I'm gonna say point. And so I'm gonna pick -2. So I'm gonna just evaluate f of -2 for the function. I'm gonna use the simplified version. So that's just going to be 3 over -2 plus 1. It's just like finding the whole, except x is a different number. And this is gonna be 3 over -2 plus 1, which is -1. Oops, almost made a mistake. and that's going to be negative 3. So we can easily find a point at negative 2 and negative 3. So I'm going to go to negative 2, and I'm going to go up to positive 3. Haha, just kidding. Did you see my mistake? Making mistakes all over the place now. So negative 2, negative 3. There we go. Which is what we had assumed. It's going to be across from each other like that. There we go. So here's our graph now. So remember, it has to go through these 2 points and through this point down here. It's approaching the asymptote, so I'm going to just get really close to the asymptote. There we go. Go through. I'm not going to go through that point. It's just going to touch it on the side, and I'm just going to continue it on the other side. And notice, oops, darn it, it's stuck. It's approaching the asymptote, so it's not going straight across. It's like approaching the asymptotes. So I'm going to do the same thing here, approaching the asymptote, going through that point right there, just like that. Yay, we're done. All right, so that's how you graph these. We're going to try number 2. Just move it over. We have some room. All right, same thing. We're going to factor as much as we can. The top right there, nothing to factor. It's just x minus 3, no GCFs or anything. So if there's nothing, you just leave it like that, right? And then the denominator, I notice that there is I'm going to just use the negative 2. We do not like x's to be negative. Makes life a little more complicated, so I'm going to just factor that out. So negative 2, and then all I have left is the x. And then this would have to be a minus 2. The reason why is because negative 2 times negative 2 would give us back that positive 4, or plus 4. All right, and as I notice here, nothing to cancel out, so that's it. So no holes. And so I'm going to be like this. I'll be like hole. No hole. That's all I have. And then my vertical asymptote, I'm just going to use this right here, x minus 2. The negative 2 does not have an x with it, so that does not affect that doesn't make the denominator 0 at all, ever, because it's going to just stay as negative 2. So here we go. Vertical asymptote, x minus 2 is equal to 0, and we're just going to, so then that means x is equal to 2. It's 2 minus 2 is 0. I'm just going to vertical asymptote right here at 2. All right, now we have the horizontal asymptote, which we made blue. I'm trying to keep the colors the same. So horizontal asymptote, we're going to have, remember we're using the first 2 terms, because those are the ones that get affected by, like when x gets really, really large, that is the big influence right there. X minus, or divided by negative 2x. I can cancel out the x's, and what do I have left? It's just 1 over negative 2. Remember that x divided by x is 1, so that's why these are just 1s. So x is equal to negative 1/2, like this. Remember the negative 2 on the bottom, we're just bringing that to the top. At least if one of them is negative, the whole thing's negative, you know. So here we go. So y is equal to negative 1/2. So we're going to go 1/2 just like this. Boom. All right. We're going to look for our intercepts. So in this case, we know our horizontal asymptote is not on the x-axis, so we know we're going to have at least one x-intercept. And if you look on so we're going to set this all equal to 0. The y is equal to 0, so 0 is equal to, I mean, technically, if I know the denominator, I'm going to multiply both sides by the denominator, and that's just going to be 0 anyways because it's going to get multiplied by 0. So I'm just going to equal it to the top. Let me just go x-intercept. All right. If you want to set it up how like we did before, with the whole thing, and then multiply both sides by the denominator, you can totally do that. This is just, you know, the shorter way to do that, less work. And so we know that x has to equal 3 because 3 minus 3 is 0. Oh, let me write this as a point. So it's going to be 3, 0. That's going to be our x-intercept. We only have one. That right there. All right, let's see what's next. The y-intercept, which I made this color. So the y-intercept is going to be something. So I'm going to use, well, honestly, it doesn't matter. I'm going to use the original version because this one, there's like some work that I would have to do with it. So if both of the x's are zeros, then literally all I have left is just negative 3 over 4. So it's just going to be negative 3 over 4. Let me just make that into a point, like that. Okay, so 0 and then negative 3 over 4. I know this was negative 1/2. It's a little bit lower than that. It's not at negative 1, but I'm trying to squeeze it in between the negative 0.5 and then the negative 1. So it's in between that. And let's see here. No holes, all that. There we go. I don't need another point because I have at least one point on each side, so I know where the graph is going to go. And here we go. Let's draw this out. Going through the, guys, it's going through that point, okay? And it's approaching the asymptotes. So this is going to be very narrow. There we go. Okay. There we go. Just make sure your graph is not curving up like this. There was a lot of students who do that. I will mark that wrong because it doesn't technically go away from the asymptote, right? You don't do that. You may have noticed, you may have been like, Miss Lee, what about the domain and range? And you're right. Totally forgot to write down the domain and range. So let's talk about that here. So the domain is for all x such that x does not equal, we're assuming that x can be all of the numbers except for, right? We're doing the shorter version, except for it has no holes, so we can't use that, except for 2. That's our vertical asymptote right there. Here we go, and our range is going to be for all y such that y does not equal to, except for, remember that negative 1/2, which was right here. So you would check your va and your ha, your vertical asymptote and your horizontal asymptote, as well as the hole for those restrictions right there. All right. If we're doing that over here for number 1, our domain is for all x such that x does not equal the 2 and the negative 1. So negative 1, 2, I like to write them in numerical order. Y, so for the range, it's going to be for all y such that y does not equal, it's going to be the 1 and the 0. So 0 and 1. 0, 1. Right, if you wrote down 2, negative 1, that's fine. As long as you have both of those two numbers there, that's fine. All right, and so we got the horizontal asymptote and the y-coordinate of the, what is it called? The y-coordinate of the graph, of the hole, I should say, sorry. All right, so there's the domain and range. Last one we're going to do is this guy right here, number 4. Number 3, you can just do on your own. I'm not doing all of them. It's already been 18 minutes. I know, crazy. Time flies when you're having fun. We're going to factor the top and factor the bottom. Always first steps are to factor. So here we go. I know both of these are going to be x's. Two numbers that multiply to negative 12 and add up to 1. Remember there's that invisible 1 there. So that's going to be 4 and 3 because I know that difference is 1. And I know that the 3 has to be negative because I want it to be a positive 1. So it's positive 4. Honestly, that's how I do it. Once I get used to the crisscross method, I just do the crisscross method in my brain. You know what I mean? So these are x's, and then two numbers that multiply to 6, which would be 3 and 2, because there's a difference of 1 there. And I know that it needs to add up to negative 1, which means that the bigger number has to be negative. So there it is. Just like that. So that's going to multiply to negative 6 and add up to negative 1. Right? If you want to do the crisscross method, please do that. That is a really good way of doing it. Just trying to save time on this video. All right. Oh, look, I can cancel something out, guys. X minus 3, x minus 3. So that's going to be our whole right there. I'm just going to write down the simplified version, which is going to be x plus 4. over x plus 2. Nothing else to cancel out. That's our simplified version. So let's go back to the whole. So whole. I know we have one in x minus 3 is equal to 0, which means x is equal to 3. And then we're going to plug that into the simplified version. So f of 3 is equal to 3 plus 4 over 3 plus 2, which is equal to 7 over 5. All right, which is like 1.4 or 1 2/5. Either way, so we got 3 7/5. We know, again, this is 1 2/3. All right, because 5 goes into 7 one time and with a remainder of 2. So 3 and 1, it's closer to the 2. There's the whole. All right, so there's the whole, and then we're going to find the vertical asymptote. Vertical asymptote, which was purple. So vertical asymptote, where whatever's left, that's our vertical asymptote right here. So we got x plus 2 is equal to 0, so x is equal to negative 2. Because negative 2 plus 2 is 0. There we go. We just know that it's going to approach that, never getting there. And then we're going to go with the horizontal asymptote. Put that right below. Let's go like this. So the horizontal asymptote is going to be, remember the first two terms right here, we're looking at that. So y is equal to x squared over x squared. And they both, that you cannot see apparently. So x squared over x squared, which they both cancel out, and all you have left is just 1. So y is equal to 1. So we're going to go here where y is equal to 1, and that is our vertical asymptote. And then we're going to look for our x and y intercepts. So x-intercept, and just put it right here, x-intercept. And that is going to be when y is equal to 0, so it's going to be 0 is equal to, again, I'm just going to equal it to the numerator just because I know the denominator is going to become 0 anyways, because if I multiply both sides by x plus 2, that 0 is going to just make it 0 anyways. So there's really no effect. All right, so x plus 4, which is the numerator, and I know that x is going to have to equal negative 4, so negative 4, 0 is going to be my x-intercept. Only one. Right there. Usually we only have one, but sometimes we have two. Depends on what the problem is. And we're going to go on to the y-intercept. Oh, sorry. I need to move more. The y-intercept is here. So the y-intercept, I'm just going to use the simplified version just because there's not much going on. If I just put zeros in for the x's, all I have left is positive 4 over positive 2. So it's just going to be 4 over 2, which is equal to 2. So that's going to be 0, 2. All right. If you want to plug in the zeros and show that, you can totally do that. If you want to just write it like this, that's fine as well. All right, so 0, 2, right there. And it should be going in this lower fashion like that. We don't need another extra point just because we have points on both sides of the vertical asymptote. So let's go. So approaching the asymptote. Remember, it's not going straight across. I have some people who just go straight across and then up. That would be wrong. Okay, that is not approaching the asymptote. It's going parallel to the asymptote, which is not true. All right, there we go. Domain and range. What is the domain going to equal? Or to be, I should say. All right, so for all x such that x does not equal, can't equal 3, and it can't equal negative 2. So negative 2, 3. Range So for all y such that y does not equal, y can't equal 1 and it cannot equal 7/5. So it's going to be 1 7/5. You can just leave it as 7/5. You don't, if you want to write it as 1.4, you can do that as well, right? All right, that's the end of graphing, guys. Please make sure you practice that. And we're going to go on to, we're not doing all the problems, guys. We're just going to do several. Here I'm going to do 5, 8, and 10. All right, so it says simplify. So what we're doing is we are going to include excluded values. All right. If I want to add these, remember I need to have common denominators. There's nothing same about them. So I know that I'm going to have to multiply this r plus 4 with r minus 6, and I have to multiply this r minus 6 by r plus 4, right? R plus 4. All right, and then what do you, so then I know my denominator is going to be r minus 6, r plus 4. All right, so then this part right here is going to be, since they have the same denominator, these are all going to go on the numerator right here. So 2r times r, I'm just distributing, so 2r times r is 2r squared, and 2r times 4 is plus 8r. All right, and then we're going to do the same thing for this one right here. So 3r times r is plus 3r squared, and 3r times negative 6 is going to be minus 18r. All right, so let's combine like terms. I'm just going to continue to use pink, I guess. So I have 2r squared plus the 3r squared. That's going to be 5r squared. And then 8r minus 18r, so that's going to be minus 10r over this denominator. And you do not need to multiply these out. You just leave them like this. All right? Makes life easier. And what are my restricted values? So r cannot be 6 or negative 4. Because we can't have r be that on the denominator, right? So r can't be 6 and r can't be negative 4. We're not doing 6, right? We're doing number 8. All right, so we're going to take a look at this. There is no GCF here. There's just the 3, so there's no common factors. So we're just going to multiply each by the other denominator. So I'm going to multiply this one by 3. I should have just done the parentheses with that guy instead of with the 3. Just saying. Because 3 is just a monomial. And then we're going to multiply the other guy with r plus r5, 5r plus 3. Right, just like that. And then so we're going to do the denominator. Oh, let me just do it with this color now. So the denominator is just going to be 3 times 5r plus 3. I like to just write the monomial one in front, so the one that's the singleton, and then the binomial like that. Just looks nicer. And then if we look at this front, the first fraction, so 4r times 5r is going to be 20r squared. 4r times 3 is plus 12r. And then same thing with this one right here. So remember there's a minus. Okay, that's going to be big. So I'm just going to go plus negative so I don't forget it. So negative 3 times r is going to be negative 3r. And negative 3 times 4 is going to be, what is it going to be? Negative 12. Right? That's going to be like the biggest thing. If that's a minus, you're going to have to, I just distribute that to the negative 3. If you want to distribute that first to the r and the 4, you can do that as well. It'll give you the same answer. You just need to make sure you distribute it to both the r and the 4. A lot of people forget the 4. Sad days for the 4. All right, now combine like terms, and we're going to get 20r squared, because that has no other like terms. 12r minus 3r is going to be plus 9r minus 12 over 3 times 5r plus 3. And the only thing that r cannot be is, we're just going to, if you want to set that equal to 0, so 5r plus 3 is equal to 0. Subtract 3 on both sides, right? So that's going to be 5r minus 3, or is equal to negative 3. And then divide both sides by 5, so r is equal to negative 3 over 5. So that is what r cannot equal. Negative 3/5. Could be anything else but that. That's the only thing that's going to turn that to 0, the denominator to 0. So let's take a look at this guy right here. It looks like I can factor that there is a GCF here. So this I can take out, do I want to write it again? Let's do it. It might get a little. So I'm going to just go 6 over. So I can pull out a 6n from both. And then what do I have left? An n minus. So 6n times what will give us a 6n back? That's got to be a 1. Okay. And plus 5 over 3n. There's no GCFs or anything. It's just a monomial. There's nothing else to do. Well, it looks like this is the GCF right here. How do we get this 3n to look like this? Well, we have to multiply it by, well, 3n times 2 would give us that 6n, right? So I have to multiply it by a 2. But then we also need this n minus 2, right? So times n minus 2. Oh, no, sorry, n minus 1. So that's what I'm going to multiply it by. So if you think about it, so 2 times 3n, that would be 6n. And then we get this n minus 1 right here. See what I'm saying? So let's simplify that. The denominator is going to be just 6n times n minus 1. Numerator here, 6, is just going to stay at 6. Nothing to multiply by because the denominator already looks like that, same, right? Plus, this is going to be 5 times 2, which is 10. Let me just rewrite this. So it would be 10 times n minus 1. Right, I'm going to multiply that. Now I'm going to distribute. So 10 times n, which is 10n. I'll move my finger. And then 10 times 1 is going to be, so that's minus 10. All right, and we can simplify that down. That's just going to be 10n minus 4, because 6 minus 10 is 4, over 6n times n minus 1. Oop, you thought I forgot the excluded values. No, I didn't. So that's going to be where n, remember, n cannot equal, we got 0, so it definitely cannot be 0. And then n minus 1, so it cannot be 1. Right? Can't be those two things. All right, moving on. We're going to 11. Let's take a look here. So this is division. Always we're going to factor as much as we can. Let me use different colors here. So we have 4 over. So I know I can factor out a 9. Also, there's 3 x's here and 2 x's here, so I know I can factor out a max of x squared. What do I have left? Well, I already got the 9. I just need one more x. And then for this one, I need minus 9, because 9 times 9 is 81. And I don't need any more x squares, so that's it. Some may think, oh, difference of squares, can't do that because this is just an x and not an x squared. So this is as much as we can do. So times, remember we're going to, instead of dividing, we're going to multiply. We're going to change it to multiply the reciprocal. So we're going to flip it. That's going to be 9x squared on top and 1 on the bottom. Now my favorite part, what can I cancel out? Do you see what I see? This 9x squared and the 9x squared, both the same, done, out. There's nothing else to cancel out, so we're just going to go equals. All right, maybe I'd like to write it on the bottom. So 4 times, should have just written 1s on those, right? because 9x squared goes into 9x squared 1 times. So 4 times 1 is 4 over, everything else is 1s except for this x minus 9, so it's going to be x minus 9. And my excluded value, or my restrictions I should say, is going to be x cannot equal 9, but it also cannot equal 0, because remember, even though we canceled it out, it was still part of the original, so x cannot equal 0. Just like that. Happy days. All right, same thing with number 12. There's nothing to simplify here, it's just 1 over x plus 6. And we can multiply by, I know that 6x squared is going to go on the denominator, and this right here, I'm just going to factor that. So actually, maybe I could just factor it right here. Let's think together. So I know that these are both going to be x, because that's just x squared. Two numbers that multiply to 60 that add up to 4 or subtract to 4. 10 and 6. Yeah, there we go. So I got 6, got 10. I know that my bigger number has to be negative because it has to add up to -4. There's plus 6. All right, so now, is there anything to cancel? Oh, this one's not that fun, but that's fine. We got the x plus 6 and x plus 6. That's all we can cancel. Remember, we do not do x's individually, like this x squared with that x squared does not cancel because it's attached to all these minuses, right? They all go together. So the only way we can cancel them out if we actually factor them. And you have to cancel out all of x plus 6 and all of x plus 6. Because this is not just x, it's x plus 6. So whatever x is plus 6, right? And so we can cancel those out. Those just become 1s. And then what do we have left? Just x minus 10 over, that's just 1, so it's just 6x squared. And what can x not be? X cannot be -6 or 0. Make sure you don't just look at your simplified version there. Oh, also, ooh, I almost made a mistake. I was also supposed to check this top. Okay, so we need it. Remember, especially when we divide, we need to check all of this. None of this can be 0 because remember, this division right here is the denominator. So I do need to add in one more. It also cannot be 10. So I'm adding that in there. All right, so we're checking all of these guys right here. Because remember, this technically was part of the denominator, right? And this part is the denominator. Yeah, so we have to check all of it. So there we go. We almost made that mistake. And then let me look over here. Nope, that was just a 1, so it doesn't matter. All right, so we're taking a look at not 13, sorry, 14. So this is factoring for days here. Factoring for days. So let's go big line, big line. I like to set mine up first. So what are these going to look like? So I know I have n's, two numbers that multiply to 40 and add up to 3, or add or subtract. So 40, that's going to be 8 and 5. This is where knowing your multiplication tables is really useful, or else you're just like spamming guesses at that point. Sad days. I know that the 8 has to be negative because that's going to add up to -3. There we go. Denominator, so that's going to be n and n. Two numbers that multiply to 48 add up to 14. 6 and 8. 6 times 8 is 48. And if I add them together, they're going to be 14. I know all of them is going to be plus because there are no negatives there, no minuses. So they're both pluses. And then next one. Oh, look, it's, wow. Honestly, could I have just crossed all this out in the first place? Yes, we could have. Didn't realize that until right now. So, but I already know this one is going to just look the same. So I'm just going to copy that down. And then bottom one is going to be n's, two numbers that multiply to 50 and add up to 15. 2 and 25 is not going to work. 5 and 10. 5 and 10 won't work. So there we go. 5 times 10 is 50. 5 plus 10 is 15. Happy days. Now my favorite part. Notice I did not flip it because it's already multiplied. So the top goes with the top. The denominator goes with the denominator. See what I'm saying? All right. Now my favorite part. Canceling things out. Boom. Boom. boom, boom, right? N plus 6, N plus 8, N plus 5, N plus 5. As long as one is on the top and one is on the bottom, they don't need to crisscross this way. If we had N plus 5 on here, like this, you could totally cross them out as well. Right, all we have left is, let's go back to this color. So N minus 8 over N plus 5. Nope, just kidding, N plus 10. Right, and what are our restrictions? So that's going to be N cannot equal all the denominators. So that's going to be negative 6, negative 8. I just go in order right here, negative 5, and then negative 10. We do not have to worry about the numerators because there's no division going on here. All right, that's how you do those. Moving on. We have 1, 2, 3, 4, 5, 6 more problems to go. Well, you have more, but that's as many as I'm doing. I believe that will cover basically all of the types of problems. So again, let's factor. I'm going to not make, so there's nothing that's the same. So now on the top, I see that I can take out a 4, and I have up to a max of n squared. So what do I have is just going to be an n, because I need one more n to make it n cubed, plus 3. Denominator, ooh, definitely a 4, and an n squared. And then all I have left is an n plus 1, right? Because 4n squared, I don't need anything else. So I'm just going to multiply by that by 1 to get the 4n squared times n plus 3, nothing to do, just n plus 3. Denominator, factor. So I got n and n. The only two numbers that multiply to 3 is 3 and 1. And since they're both positive, I know they're both positive. Just to check, 3 plus 1 is 4, so we're good to go. Now my favorite part, canceling out. So I have, 4n squared, those just become 1s. This is my favorite. Oh, so sad. Can't cancel these out because they're both in the denominator. Remember what I was talking about before? Can't do that. So all I have left on top is going to be n plus 3. Actually, I don't know if I said that before. I did in class. So this is all we got. My restrictions are going to be, well, n cannot equal, obviously, negative 1. You don't need to put in multiplicities because we don't care. We're not graphing. And then right here, n squared, that's going to be 0. And we have the thing that we canceled out right here, which is negative 3. So those are the 3 numbers it cannot be. Again, we do not need to check the top just because this is not division, this is multiplication. All right, now we're getting into equations. So let's think. I like to, I'm not going to find common denominators and then have one fraction. I mean, you can, but I'm just going to get rid of the denominator. Ah! Sorry. Announcements are being made. As you can see, I'm at school trying to do this. All right, so right here, I'm the GCF right here, or the greatest common factor? Nope. LCD, the least common denominator. So I know all of them, these two have a 2, so I know I definitely need to multiply by 2. And I also know that I have at least just an n. So I multiply both sides here by 2n, and this one right here by 2n. All right. So if I distribute this, I know my 2's are going to cancel out for this fraction, right? Because 2 divided by 2 is 1. And all I have left is n. So n times 1 is just n. All right? And then 2n, and then divided by 2n. So that's just cancels out to be 1. So all I have left is just minus 1 is equal to, over here, my n's are going to cancel out, and all I have left is a 2. So it's going to be 2 times n. So I'm going to distribute the 2. 2 times n is 2n. So I'm going to just cancels out. And then 2 times 6 is going to be minus 12. All right? And then I'm just going to solve. This is like algebra 1, right? I'm just going to solve for n. I'm going to subtract n on both sides. I like to get my n's together first. The reason why I subtracted n is because if I subtract 2n, then I have to deal with negative numbers. I really don't want to do that. 2n minus n is n minus 12. And then I just need to get rid of the minus 12, so add 12 to both sides. And running out of room. So I get, just gonna put the arrow there. So I just get n is equal to, because n is equal to 11. And it just says remember to check for extraneous solutions, because in case this, if I plug it back in, will it give me a 0 in the denominator? And no, it won't. So this is not an extraneous solution. So there we go. N is equal to 11. Solved. Done. All right. The only thing I need to do here is to I'm going to just factor out the GCF. I know that these two are exactly the same. So I'm just going to go, well, I know that 2 goes in all of this, so the GCF is 2. I get n squared minus 7n minus 8. So that's the same thing with this one. So 2n squared minus 7n minus 8. I would factor more, but I'm not going to, because all I know on the left-hand side is just a 2. So I know that I'm going to be multiplying by a 2 for sure, right, plus all this. And this, the 1/2 doesn't have any other variables, so I'm just going to make my life just a little bit easier. So I'm going to multiply by, let's see, let's multiply by this one. Multiply the left-hand side by all of this. 2 times n squared minus 7n minus 8. Over here on the right-hand side as well. 2 times n squared minus 7n minus 8. Right? And so when I look at that, what's going to cancel out? What am I use pink? So I know the 2's are going to cancel out, right? Because 2, 2. All I have left is all this times 1, which is pretty much all this, right? So n squared minus 7n minus 8 is equal to, oh look, the denominators just all cancel out because it's exactly the same, right? So all I have left is 7 plus n minus 6. Much easier, right? The reason why I didn't factor, because ultimately I would have to multiply that back together again anyway, so there's no point in that. So now I'm going to just get one side equal to 0 because I have a quadratic here. So I am going to, well, let's take a look here. N squared minus 7n minus 8 is equal to n plus 1. I'm just combining like terms on the right. I'm going to do two things at the same time. I'm going to subtract n, and then I'm going to subtract 1, if you guys don't mind. I'm going to do those two things at the same time so I could just get the right-hand side equal to 0. So I have left n squared minus 8n minus 9 is equal to 0. And as you can see here, I have a quadratic. So yes, we're going to have to factor. We've been factoring for days, right? So this I know is n. Two numbers that multiply to 9 and add up to 8. My only option is 9 and 1, right? Because it's not going to be 3 and 3. I can't get 8 with 3 and 3, right? So I know that the 9 has to be negative because it's going to have to add up to negative 8. That's going to be positive. Again, zero product property. So I know that n minus 9 is equal to 0 and n plus 1 is equal to 0. Honestly, if you want to use the quadratic formula, you can, but it's going to take forever and a day. This is just much easier and faster. So n is equal to 9 and negative 1. And just to make sure, will that give me a 0 here or an extraneous solution here? Ooh, that's a good question. A 9, if I put that in, I know I'm not going to get a 9. 8 does not multiply, but negative 1. Ooh, negative 1, negative 1. If I put a negative 1 in, there, it's going to be negative 1. Maybe I should have factored. It would make life a little easier in this case. And then that's going to be 7 times negative 1 minus 8. That's going to be positive 1. Ooh, plus 7 minus 8. So that's going to be 8 minus 8. Ooh, that makes the denominator 0. Can't have that. So that's an extraneous solution. Do you see what I'm saying? So if I plug back in the negative 1, that's going to make the denominator 0. So it's not going to be negative 1, it's just going to be the 9. Just like that. And now you know. All right, for number 22, I'm going to do the same thing. I am going to factor out the denominator. So I know that 3 and 12 both go in there, so it's going to be 3 times r minus 4. This also is the same thing, so 3 times r minus 4. And this is just r minus 4, so we're fine. So what am I going to multiply by? 3 times r minus 4. That's what it's going to be. So we multiply the left-hand side by 3 times r minus 4, and the right-hand side 3 times r minus 4. All right, and so this is exactly the same. So I can cancel out the denominator, and all I have left is r squared minus 7r plus 6 equal to, again, these denominators are the same, so those cancel out. All I have left is r squared plus r. And here, only the r minus 4 cancels out, so I have the 3 to distribute. Please don't forget that there's a minus there. Go again, plus negative, right? So then it's going to be negative 3 times r, which is negative 3r, and negative 3 times 1, which is going to be plus 3. Running out of room. All right, we're just going to I'm going to simplify the right-hand side. So r squared, r minus 3r is going to be minus 2r plus 3. I'm going to just get everything on one side. So I'm just going to be like minus r squared, or it could be like, oh, cancels out, and plus 2r minus 3, right? These all cancel out to be 0. I'm running out of room. And this is going to be, oh, nothing, and negative 5r, and this is going to be plus 3. Oh, look, it just is a linear equation. So I'm going to just solve for r. I'm just going to put this over here. So negative 5r plus 3 is equal to 0. Subtract 3 on both sides, right? So you get negative 5r is equal to negative 3. Divide by negative 5. So r is equal to positive 3 over 5. Why is it positive 3 over 5? Because they're both negative. Negative divided by negative is positive. This, if I check it back in here, yeah, 3/5 is not going to make that 0, so that's my answer. Usually when you'll see extraneous solutions is when you have a quadratic. One of them will work usually, and one of them may not work. Sometimes both of them work, but that's usually when you would get extraneous solution. When you're dealing with linears, usually not going to get that. All right, 2 more problems. I'm not going to do that. I don't have much room. I'm going to just go to number 26. Okay. All right. So I'm going to factor this denominator right here. X and X. And this is going to be 3 and 15. Oh, 3 and 5. I'm just kidding. 3 and 5. I know added up together will give me 8. This is exact same denominator, so it's just 3. Oh, sorry. Sorry. X plus 3 is equal to x plus, or it's times x plus 5. And this is just x plus 3. And there we go. I notice here, I'm going to multiply both sides by, where's my equal sign? Plus 3 times x plus 5. Multiply this one right here as well. X plus 3 times x plus 5. And happy days, these all cancel out over here on the left-hand side. I just have left whatever's in the numerator. Oops, no need for parentheses. Plus 7x. On the right-hand side, only my x plus 3's cancel out. So I have left x plus 6 times x plus 5. So I'm going to have to multiply them out. So equals x times x. X squared. X times 5. 5x. And then I'm going to, so this cancels out, so I don't get confused. So 6 times x which is 6x, and 6 times 5, which is 30. All right, and then I'm going to start canceling things out. Or before that, I suppose I should, simplify. So we got x squared plus 5x plus 7x is 12x minus 6 is equal to x squared. This is 11x plus 30. All right, I'm going to move everything over. So I'm going to go subtract x squared, subtract 11x, subtract 30. These become 0 is equal to, cancels out, all I have left is x minus 36. So if I were to add 36 to both sides, x is equal to 36. And I know if I plug in 36, that is not going to give me, a 0. All right, and that's definitely not an extraneous solution. Remember, all your answers are here on the back. Please check. If you find a mistake, please let me know. 36, see? And there we go. Good luck. Do well on the test. Bye.